Okay, hello everyone. We are going to start in a few minutes. I hope you can hear me. You looked at the Google files and you don't see WI data. Okay, let us look at together. Okay, let's look at together. Just 1 second. So this is last week's material, week 1. I'm just going to use, I just added one new file in here, and here's the data set. Okay, now I'm going to share this with you. Okay, so I'm sharing this with from the chat. So this is week 1, module 1. So let me write it nicely, module 1. All right, and then I'm sharing today's material. It's module 2. Just give me a second. Again, you're gonna see what I'm sharing. So this is week 2. So this is today's material, okay? Some small data sets. They are all small data sets. And this is session 2. All right, and let me share this with you. Okay. So this will be module 2. Okay, so you have both modules now. So those who just arrived, I shared the files. I'm going to share it again. So for those who just joined. So let's wait for 1 or 2 more minutes because people are still joining in. Today, I am literally in the middle of woods up north of San Francisco. And I hope the internet connection is going to be stable. The light is not so good up there, so you're seeing me a little bit blurry. Sorry about that. So I'll do my best, but if internet connection goes away, so we're gonna meet next time, okay? So next week maybe. So I'm planning to have 3 more modules. Today is going to be the 2nd module. I'm planning to have 3 more modules on time series. So we are going to continue with data exploration for time series data sets today. So be patient. So we are going to get into more sophisticated topics like forecasting models in our upcoming sessions. But before doing anything, I think we should be very comfortable with data manipulation. So I'm going to spend time today with data manipulation. All right, so what I'm going to do today at the beginning is I just want to go over what we did last time. So I prepared 2 short questions for you guys. And I also put this file into the first module folder. So you can find that this file, let me close this. And by the way, if you could please ask your questions using Q&A. I can see your questions because in the chat, there are so many messages might be shared. Your question is going to get lost. I'm not going to see your question, most likely. So please post your questions on Q&A. So please open this file, session 1 EX. I'm going to be using WDI, World Development Indicator data, which we used last time. Again, these are things that we did in our last session. I just picked a couple of things that we did from last time just to remember what we did. Okay. All right, so let's get started. I'm going to first load the data sets using pandas. Okay, again, my assumption is we are all new into time series and we are also struggling with pandas. Okay, that is my assumption. So if you guys already know in and out about pandas, and then if you guys already are familiar with data manipulation for time series data sets, sorry about that. Okay, so I'm going to take my time to go slowly, and then again, I will assume that all of us are new into this topic. This session is recorded, and then it's going to be shared later at our YouTube channel. All right. So let's load the data set. So WDI data. So first of all, I'm going to import pandas. So PD is the alias that I'm using for pandas, and let's also import NumPy. Okay, so I imported these 2 libraries. Again, these 2 libraries are going to be your best friends, all right, when you are dealing with data sets. And then let us now read our data. So I'm going to use pandas to read CSV because I'm going to be reading a CSV file. Okay. And then here is the file. This is the name of the file, WTI data.csv. Okay. All right. So we just read the data set. We got the data in the notebook. So what am I going to next is here it says how many unique country codes are there. So I'm going to just find the unique names of countries because this data set, let's check the shape of the data set. It's a fairly, large data set, right? So there are 377,000 records and there are 65 indicators. Actually, indicators, and each country has 65, records for each country. So let us find the unique number of countries now, right? So for that, I'm going to take my data, and then I'm going to slice the country code column, okay? Country code column. Actually, there are less than 65 indicators. Some of the columns. Hello again. So I'm sorry about this, but the internet connection was gone for the last maybe 15 minutes. I didn't know you guys were waiting. So thank you for waiting. Let us do this. Let us continue as much as we can. Okay. But if internet goes away one more time, keep in mind that we are not going to meet today, and then we are going to continue next week. Okay. But as long as we have the connection now, let's continue. So I'm going to use the again for those who just joined, we are using the a file with 2 questions to review what we did last time, and then I just uploaded the data set. I just read the data set, World Development Indicator data set, and then I was checking the number of countries, unique country codes in the data set. So today's topic is data analyzing or exploring the time series data sets. Okay, there are 264 unique countries. So what I want to do is now, as we did last time, I'm just going to take a slice from this data set. I'm going to use the indicator name, as I said in here, central government debt. Okay, so I'm just going to take this part of the data set, and then I'm going to focus on later from this data set. I will filter a little bit more and then focus on US data set. Okay, so let's do it. And by the way, if you have any questions, please feel free to post it on Q&A. Okay, so let's take our data, okay? And remember, there are 377K data points in this data set. I am going to take a certain part of my data set. So what part of this data set? I'm going to focus on the part where data indicator, okay? Data indicator name, or let's call it indicator name. Okay, indicator name is going to be this equals, as I said, because this is long, I'm just going to copy it from here, and please, you also do the same. I'm just going to copy this. So this is one of the indicators. There are around 60 indicators, and that is the indicator name where central government gets as a percentage of total GDP. Okay, I just copied this. All right, so I'm just going to take the part of the data where indicator name is central government debt. All right, so let's do this. And let me also assign this to a new variable so that I can use this. Let's call this central government debt. Okay, let me quickly finish this so that we can start with the new topic. Okay, next thing is I want to assign, as I said in the question, okay, I created a new data frame. Now I want to assign the country code as the index for this data frame. So first of all, let's see how this data frame looks like. Government debt.head. Okay, so let's see how it looks like. As you see, we have the index numbers indicating each index number is corresponding to one row. Instead of this index number, I want to use the country code as the index. Okay, that's what I'm going to do. So what I'm going to do is I'm going to take my data, that, and then I'm just going to say its index is central government that country code. And it gave an error because we made a mistake here. All right, so we changed the index. Let us check one more time, the first 5 records. And now I have the country code as the index. So probably you don't have the file in your folder, Sonia. So please make sure that you download the entire file. So probably you are running this maybe in your folder where you are running, you don't have the data set. So you have to point your path to where this data set is now. My suggestion is download module 1. Module 1 already has this data set, so you can simply write the same code I'm writing. So you don't have to change or define any path. Okay, it is going to, this code is going to run within that folder. All right, let's go to the next question. This is just a simple review of what we did last time. All right, and the next question, what I'm going to do is now I'm going to select from the data set that I just created, this central government debt. I'm going to again take another slice from this smaller data set, which is corresponding to year 2010. Okay, and by the way, I'm also going to eliminate the ones which are null. Okay, from this new data frame, I'm going to eliminate the ones which are null. So first of all, let me get the 2010 data set, central government debt. So this is the data frame I got from the bigger data set. And I'm going to filter this further to only data points for year 2010. Okay, is equal to you need to check how the data set looks like. Okay, so this is my central government debt. This is country code. And there are columns here, columns for different years, 1960, 1961, 62. I'm going to pick the column corresponding to year 2010. Okay, in other words, I'm just going to take one slice, one column from this data set. Okay, and that is 2010. Perfect. So I got one slice. So now let's see how the data set looks like. Let me run the entire thing. So as you see, I have the country code and 2010 column. So for some reason, the first 5, values and the last 5 values or observations in this column do not have any numeric value. That means these countries do not have data for 2010, do not have central government debt data for 2010. It doesn't mean that I don't have any data in between. So for only these countries, I don't have any value, okay? All right, the next thing is I'm going to focus on the US data set. But before doing that, I told you, right, before doing that, we want to eliminate the null values from this one. So how can I do this? I'm going to write this part one more time, but in a different way now. So now you see that if I don't eliminate the null values, how it looks like. Now I'm going to write this in a different way. What I'm going to do is from this column, which we just saw in here, I am going to select, okay, I'm going to select only the ones which are not taking any null value. So for that, what I'm going to do is, first of all, I need to select the null ones. For that, I'm going to use pandas null is null method, okay? And then this is null method is going to run for this column. So any of the rows in this column, any of the records in this column, if there is a null value, it's going to give us true value. If we don't have any null value, it's going to give us false value. Okay, so let's run this separately here so that we understand what is going on. That is going to take central. That's 2010. All right. So I just took central government debt 2010, and then I'm just curious if there are any null values here. So as you see, if there is a null value, it says true. If there is not a null value, it says it's gonna say false. But we don't see false because we didn't see the non-null values in here, right? Okay. So let me just copy this and then bring it over here. Okay, and then let's run this. Now let me check how my data set looks like. Okay, they're almost there. Oh, still no value. Oh, I need to negate this. Right now, I only selected the null value, so I need to take a negate of this. That means I am only taking the non-null values. Here, this part is giving me the null values. I'm negating this, and this way I'm going to select the non-null ones. So let's, okay, I need to run this one more time here because now we have all null values. All right, and this. Okay, as you see now, I only have the country codes without any null value. So each of these country codes is assigned with a value, right, for government debt in 2010. Okay. All right, we are almost there. Okay, now I want to, from this data set, this very last data set, I want to select only, not from this data set, I'm going to go back to my original government debt data set, not just 2010, but this time I'm going to, here, I took a slice from the time 2010, right? Next, I'm going to take a slice horizontally from my data set. I'm just only going to select the data set corresponding to USA. Right now, I took a perpendicular slice, right? Just one column for a specific year. Next, I'm going to take a horizontal slice, which is corresponding to only USA. That's what I'm going to do. So central government debt, okay. I'm going to select the data points corresponding to country code equals USA. Okay, that's what I'm going to do. So similarly, again, I am selecting now the country code equals USA. By the way, I need to use this. Okay, so central government, that's the country code is USA. Okay, so let's assign this to data US. Okay, I just got data US now. Let's see how it looks like. Okay, as you see, I have only USA, and then I have the indicator is central government debt total. That's what I selected at the very beginning. And these are the data points. Again, as you see, for certain years, I have null values for USA, and for certain years, I don't have any null value. All right, let's continue. Next, what I'm going to do is I am going to take the transpose of this data set. Okay, so as you see now, I have a single row. What I want to do is I want to take the transpose of this data set so that I can turn it into like a column vector. Okay, so that's what I'm going to do. It's very simple actually. What I'm going to do is I'm just going to add this dot T. T is going to take transpose of this entire row. Okay, let's do it. Perfect. Okay, now you see the index of the data frame is now changed to the years, right? And the value of the column, the name of the column is now USA. All right. Okay, so that is going to give us flexibility in terms of selecting the year. So I like to work with data sets when the index is equal to. So when I have the what is that? If I want to select a certain part of the data set, I like doing this in terms of rows. So what I want to do is I want to only select the data in between 1960 and 2010 for USA. Okay, that is the next thing which I want to do. So what I'm going to do is last week I showed you a different way, and then one of the person in the audience suggested an easier way. Actually, I just wanted to show last time the longer way so that you know that there are other options available. So let's use the shorter way this time. So what I'm going to do is data US. I'm just going to select. Okay, this time I'm using ILAP because I am going to specifically use the index values. Okay, I'm going to select from 1960. Okay, sorry. To 2010. Okay, I'm selecting data points from 1960 to 2010, and let me also make this what is that equal to D.
Duvar var. Önünde bir tane tek bir tane ürün olduğu için herhalde.
İşte.
Duvarda onu da elleyemeyenler. Çünkü onun da arkası kapalı. Ya böyle
1960.
Öyle değil mi?
Check
O
this one more
Morse
time.
reklamı yapıyor sol tarafta ekranda. Morse önünde bütün makinesinde de şey var. Spotter. Kimse ellemesin. Kendi çizimi.
Okay. 1960. Gonna be 1960 to 2010. I log is 4. Now I'm using the index values because I changed it already. So sorry about that. I have to run this one more time and then hopefully this will work. Yeah. Okay. Sorry about that. Let me assign this to the US. Okay. Let me run this one more time. And then here. Okay. So now I got my data set only from 1960 to 2010, the country code. Actually, I should change the name from country code. It doesn't make any sense anyway. So you can change the index name, but let's not bother with that right now. Okay, so the next thing is I have some null values here. I want to turn these null values into 0 so that I can plot it. So at least there is a reason for that. If you are comparing two countries, let's say there is another country and that country has values for some of the missing values for USA. So for example, USA doesn't have a value in 1960, but another country has value for 1960. When you want to plot these two countries' central government debts to compare them in a plot, if you don't turn this not a number value, this missing value into a numeric value, so USA's data, the plot is going to begin from 1989. So you can try, and then the plot for two countries is going to be really misleading. I think last time we already, I mean, I gave you an example on that last time, so I don't want to get into it now. Okay, next, let us change the missing values with 0. So I'm just going to fill all missing values with 0. Do this in place. That means whatever I make a change here, it is going to be permanent on the current data frame. Okay, so now let's check the data US one more time. As you see, I have all the missing values filled with 0. And now let's just plot this. So what I'm going to do is I'm going to take this data frame and then plot. So you can simply plot it, right? It's going to look something like this. Let's make this a little bit nicer, okay? So what I'm going to do is I'm going to say lifestyle is this, and I'm going to let's use a marker, this, okay? And then I'm going to change the color to this. Okay, all right. So this is USA, and then that is the central government debt as a percentage of total GDP from 1960. Again, I'm totally stranger to this context. Okay, so government indicator or development indicator data set. So from a context that I'm totally stranger to, we took some data and then we explored it. Okay. So that is the very essential first step that we have to do when we are dealing with any type of data set, but there are certain things we need to do for time series data sets. So now let's continue with how we can explore time series data sets. And then I'm going to just jump to our next topic, okay? Loading, exploring time series data sets, looking at some date and time features, how we can parse strings into time, how we can deal with date formats for a time series data set, and then how we can take rolling averages for observations, whether we can use this rolling averages or moving averages to make some predictions, how good those predictions are. Again, very simple data exploration. We haven't even started with talking about any forecasting models, which we will do, all right, which we will do. But again, we have to be very comfortable with dealing with data sets first. Please let me know if you have any questions at any point or any suggestions. Okay, now I'm going to use some different, let me see where is one. So let me change my folder to week two in class. Again, if you don't have these files here, please let me know. So if you have not downloaded these files, so I'm gonna work on session 2 file, and these are the data files which I'm gonna be using. Okay, now let's load this time series data set, the daily total female birth. These are very short, I'm sorry, small data sets. Again, our goal is learning how we can manipulate, aggregate, change the types of the data sets, types of the columns in the data sets. Okay, first of all, let's import pandas. Okay, I'm going to load my data set. Okay. So my data set is daily total female. Let me just copy this. Please do the same thing. It's better to just copy it here. It's going to be too long otherwise. Okay, so let us say this is my, what is that, birth data. Let's call this B data. Okay. Okay, let's see how the data looks like. Okay. So here is the data set. I have observations. So these are the index numbers for each row. There are only 2 columns, date and births. So let's see what are the types of these columns. Okay, so B data. Sorry. B data. So date is in terms of object. It is not a date type yet. Okay. And then so that it means right now it is a string, and births is integers. Okay, all right. And then there are 365 observations. If you look at the data, it is actually giving us the whatever the births or total female births, daily total female births on this year, on this month, on this day. So we had 365. Let's check the tail. So as I said, the same year, 12th month, 31st, that means 365 observations for one full year. Okay, but I want to actually read this data set in a way that I want to turn this date into a date format so that we're gonna see later on how we can, what is the advantage of having a date format for time series data sets. And also I want to assign this date as an index for my data set. Okay, I want to do that. Can you do this after you load the data set? Yes, I'm going to show that. But you can also do this change as you are reading the data set. Okay, so let's do it first the easy way. As we read the data set, let us change the date text into date format and then assign it as the index of the data set. Let's do it that way. Okay. Yeah, location of the files. Let me post the module 2 link for you, Rihanna. So there are some information on seasonality from. I'm aware of that. I'm going to come back to that. So don't worry. We are going to cover a good amount of time series. Okay, and then share us the link where we can find it. Okay, let me share it quickly. Oh, the links already got lost because I got disconnected. So let me share it very quickly, just 1 second. So this is from last week. This is one. Okay. Now I'm going to share module 2. Oh, I'm sorry. This is module 2. I need to let me delete this module 2. This is module 2. This is this week's material, and this is first week's material. Let me share this.
Şeyde demiştim. Öğrencimde finansları biraz sohbet ediyoruz. Ayrıca
This is module 1. So I just shared with you guys module 1 and module 2 if you did not have the data sets. All right, let's continue. We were trying to read the data set, and as we read this data set, this small, simple data set, we want to change the date, which is in this, currently it is string. We want to change its type from object to date time. Plus, we want to assign date as the index for our data set. That is what we want to do. I told you that we can do this in 2 ways. First, after we read this data set, as we did any CSV data set that we did before, and then make the changes later, or we can read the data set in such that the date is gonna turn into a date format, and then will be the index of the data set. So let's use the simpler way first. I'm gonna read the data one more time. Okay, pandas read CSV. Okay, and please just copy this part because I don't want to waste time with writing this. Okay. So this is my data set. Next, what I want to do is I am going to say my index column is this column, which is date. So I want to assign date as my index column. Next, what I want to do is I will also say parse dates is true. So wherever the date is, I want to turn it into date format. Okay, so that's what I want to do. So let me read my data and then just very quickly check the head of the data set. So as you see, index column is changed to date, and also let's also check the
bir de bu şey var. Bir dakika.
So as you see, the index is changed into date format. Not only that, but data type for the index is date time format. Okay, we have a lot of advantages of turning date into date format. So we are going to see that. All right, we are going to see that. Okay, so that is the first thing. So what else? We are going to explore this this data set. So we just did. So let's check the let's just say media data that describe. Now, a lot of times when we first start with machine learning or time series models, so I received this question. So why are we using this describe? What is the goal? So why are we doing this? So I want to get a good understanding of my numerical features here, right? So I have 365 number of data points. This is the mean. So I need mean later on. So this description tells me that number of births across 365 days is centered around 42, and then has a standard deviation of 7 point. In other words, from that center, if I go to right and left, almost 95% of my data points are falling within that range. Now, why am I spending time to explain this to you? Later on, then we are going to use, say, a linear regression model to make a prediction, which we are going to do. And then let's say you've found the score for that linear regression model. Let's say some root mean squared error. Root mean squared error is going to be some number. Okay, let's say in this case, I'm making some prediction. The prediction is I want to find out how many births, female births happening in a certain day. Okay, give me the day, I'm going to give you the prediction. So that is how it's going to work. So my predictions, I'm going to compare these predictions with the real values, true values, and I'm going to get some score using some score metrics, say RMSE. I'm going to get some value. Let's say my RMSE came out to be 8. So what does that mean? Is 8 good or bad? Who can tell me is 8 good or bad, right? So for that, what I can do at least is if the RMSE, root mean squared error, which is the error, average error between my predictions and the true values. Take that difference and take the square of that, add that up across all data points, okay, divided by number of data points, and then take the square root of that. That is RMSE. So RMSE is giving me an indication on how much my predictions are deviating from, on average, deviating from true values. Now that deviation is 8. Is it good or bad? I can't say, oh, the average is 42 and standard deviation is 7.3. So if I had used the average value as prediction, if I had used the average value as prediction, say 42, on average, my predictions will be 7.3 to the right, 7.3 to the left. On average, most of my predictions are going to be between 7.3 to the left and to the right of 42. In other words, RMSE of 8 may not be a very good model, because instead of running and training a model, I could simply use the mean value as my prediction. Okay, so it is important to know your data set as you are training your data set with some machine learning or deep learning models or some time series models. All right, so let's continue. Let's continue. So so there are some question here. Can't repeat what you have said about mean and standard deviation. So mean is the center of my data set. If I had created a histogram of my data set, mean is the center, and standard deviation, so let's say 42 is the center of the data set. You go 7.3 to the left of the mean, 7.3 to the right of the mean. So between that 7.3 left and right, almost 95% of your data points are going to be located. So that means one standard deviation to the right and left of the center is going to hold majority of your data points. Okay, so let's continue. The next thing is, let's see what I'm telling here. So query your data by time. So I want to query my data by time. What it means is I want to select a certain data point given a certain date. So that's what I want to do. So what I want to do is take my data, okay, and I would like to take the data points which are falling corresponding to a certain month. So again, the year is already 1959. We know that, 1959. But I want to, let's say, only select the data points corresponding to February. So that is the beauty of using a date format, okay? So here, I just selected 1959, that's the year, and the date is 0.2. So anything 1959, 0.2, beginning with 1959, 0.2, in other words, February, is going to be listed here. So as you see, I have all the data points corresponding to month February in year 1959. Right? So I just wanted to show you how you can actually query data sets using time. Please let me know if you have any questions at any point. All right, let's continue, guys. And would you please share us the link? Oh, okay, I already answered this question. Okay, now, next. So we slowly getting into data exploration. So we have some idea now. Let's continue with this. I'm going to import at this point another, what is that data set? Daily minimum temperatures. I didn't, it's here. Use the data set daily minimum temperatures. Okay, let's do it. That now I'm gonna import, even though I imported earlier, pandas. I know that I imported earlier. It's okay. I want to have do some practice. So import pandas SPD, okay? Not APD, SPD. And I'm also checking my time. It's 50, passing 50. So let's continue for another 40 minutes again, as long as internet connection allows me. Then I'm going to stop, okay? In 40 minutes, I'm going to stop. It is 12:50. In 40 minutes, I'm going to stop. Okay, pandas SPD. Let me read another data set, daily minimum temperatures data set. Let's do it. My data frame is pandas read CSV. Now we know that we can, as we read the data set, but how do you know the data set has, date column, right? So maybe you open the data set in the CSV format. If the data set is small, you know what the columns are. Otherwise, my suggestion is just plainly load the data set. So let's do this way. Let's plainly load the data set just to see how my data looks like. Okay. So I don't know what this data set is about. All right. I'm just reading it now. Oh, very similar to what I had for the birds data set, right? Luckily. So again, date and this time temperature. So this is daily temperature. So our data sets are not going to be as simple as this. Again, we are learning. Okay, so now I know that there is a date column which may not be as date, by the way. Okay, doesn't have to be. So let me do the same things I did earlier. So what I'm gonna say is my index column is gonna be the date, and also I'm going to parse the dates. Anything looking like date, I'm gonna turn them into date format. Okay, so this is true. Okay, I got my data frame and I have my, what is that, date as the index of my file. How to query all data of first day of month using date time index. How to query all data of first day of month. So again, I don't think you can do it this way. So I understand you. So let's say you have multiple months, and then you want to just select the first day of month each. So for that, you need to write the query. Okay, you need to write the query. Okay, if I have time, or maybe in our next meeting, we can do some query on selecting certain parts of the date. So let me put together a couple of questions and then go over them together. Okay, I'm going to take a note on that. Just 1 second. So let me take a note on that before I forget. So, the next thing we are going to do, it may partially answer your question, SA, your question. I don't know your name, so I'm just saying SA. Partially may answer your question, because right now what we are going to do is we are going to create new columns from this date index, and then columns are going to correspond to month, and then what is that, day, so that you can easily select all the data corresponding to the first day of the month. Okay, so let's do it that way. So what I'm going to do is I'm going to create a new column. Let's call this month. Again, there are different ways of doing these queries depending on how well versed you are with Python. Okay, so I always go with, to me, I like working with the most obvious one, because I'm not a code developer, so I'm only using Python to solve my problems. So df months. So what I'm going to do is I'm going to take the month portion of date. So again, you can do in this different ways, but I'm going to use list for that. So what I'm going to do is I'm going to take, go through all these indices, and then only select the month portion of that. So how am I going to do that? What I'm going to do is I'm going to say df.index. So that is the index of this data frame. And then I'm going to go over each of these indices. So let's say I, what is I? I is going to be in the range of my data set. Now, what is the length of data set, right? So I am going to go over each of these indices one by one, right? And then I is corresponding to, say, first 0, then 1, then 2. So right now I am selecting the first index and then the second index, but from each index I will only select the month. Okay, so because this is in date format, date format. So the first one is year. So we know that it is year, and the second one is the month, and the third one is the day. Okay, so let's do this way, and then it gave us an error. Let's see. What did I forget in here? So df month is df index I dot month 4. Forgot to put the 4 here. Right, so I'm looping over all indices, and then for each index, I'm pulling the month. So let's check how this file looks like. Now I just pulled the month information from the date and then copied it into a new column. So let's do the same thing or similar thing for day. Okay, so this time I'm going to call this day. And instead of month, I'm going to say day. You can do the same thing for year too, right? Okay. Now I have the month and the day. Now, could you explain parse dates? Yeah, say thank you for 4. So parse date is, I'm going to come back to this one. Here, what it is doing is, it is taking the string. Here, our data is, where is it? The date is, in my data set, anything looking like in date format, in string, is changed into date format. So that is what it is doing as we are reading the data set. Okay, but later on I'm going to show you a couple of examples where we're not going to do it this way. What we're going to do is we are going to first read the data in plain format, and then we are going to change a selected column data type from, say, string into date type. Okay, we are going to do this more explicitly. Right now, I don't want to get into it, so I want to focus on a different thing here. So later on, we are going to do this more explicitly manually. First, read the plain data and then change the date type. Okay, so answering your question, this is a old, the long way to answer the question SA, right? So now I think you can select all data points corresponding to day equals 1, right? Now I just selected all my data points which corresponds to the first day of each month. Again, this is the long answer to your question. I think there is a more elegant way of answering this question. Okay. So let's continue. The next thing is something that we haven't seen so far. Okay, and this is something you're going to use it frequently as you are dealing with time series data sets. I mean, no matter how big or small, complicated or simple the problem and data set is, you're going to use the following for when you are setting up a model. You might need, for example, temperature from yesterday. To predict temperature today, if I know temperature from yesterday, it's going to be very helpful. Even not just yesterday, but the day before yesterday. To predict the sales for today, if I know the sales yesterday, it's going to be very helpful, because most of the time series data sets come with a trend. So you cannot simply use one row of data to make your prediction. So it's better to incorporate target value that you want to predict from previous time periods into your prediction. Okay, so for that you are going to create lagged versions of your target variable of any of the columns. So let me show you what it means in a minute. So what I'm going to do is I'm going to take my data. I'm going to select the 10th column, which is this one. Okay, and then what I'm going to do is I'm going to take the first day's temperature, and then open another column, take the first day's temperature, and then add it as a new data point or record for this column. for the next day. So the next day's row is going to include yesterday's temperature too. So this will be extremely helpful when you are, creating a model, which you might use yesterday's data or the day before yesterday's data. So that's what I'm going to do. I'm going to select temperature column of my data set, and then I am going to shift it by 1. So what does that mean? Incredible, right? So what we did is we shifted our data. So let us also see how the temperature looks like. Okay, so this is the shifted version, and this is the original version. So for 1981-01-01, the value for temperature is 20.7. What I did is I took this 20.7 and then shifted it 1 day further. So instead of 0101, now 20.7 is recorded for the day 0102. So I know that this is yesterday's temperature. So I'm going to put a column name meaningfully reflecting what is happening here. Okay, so that I'm not going to get confused. But actually, this is shifting my data by 1 day. So you can do this by 1 day, by 1 week, by 1 quarter, by 1 year, depending on what you're doing. Okay. All right. So I shifted myself. We just learned how to shift our data set. So what we're going to do is let's make this more official looking. Okay. So what I'm going to do is I'm going to take my data and I'm going to shift this. By the way, you can shift it further, or you can shift it backwards. Okay, you can shift it ahead or backwards. You can do both ways. Okay, I'm going to shift it ahead by 1 day. Okay, and then I'm going to turn this into a data frame. Let me turn this into a data frame, so that I'm going to use this as a data frame later. It's going to be easier for me to manipulate this. Let me call this df lag 1. Okay, so and then I'm going to also call the column name for this df lag 1. Okay, because there is only one column, it's easier for me. This is going to be temp plus 1. Now let me see how df lag 1 looks like. And it gave me an error. It's not df temp. What happened? df temp shift by 1. Why is it? Oh, I shouldn't use square brackets. Okay. So I meaningfully named this column as temp plus 1. So I created a data frame because I want to deal with data frames. I can concatenate them. It's easier for me to deal with that. So this is one data frame which only has my temperature as one column for corresponding days, but shifted by 1 day. So next thing is I'm going to combine my original data set with this new data frame. Okay, so let's do it. So my new data frame is going to be a concatenation of 2 data frames. So the first one is the original data frame, all right? And the second one is the lag 1. Okay, lag 1, is it lag 1? Okay, and this concatenation is going to be on axis 4. Okay, now let's see how my data set looks like. Always check your data sets. So later on, you can delete all these df.heads, but always check how your data set looks like. Okay, here is my original data set with temperature, and here is temperature plus 1. As you see, 0101's temperature is recorded as a new column, value for the new column for the next day. Okay, so I can predict today's temperature in a model. For example, let's say temp is your target variable. I can predict today's temperature by using yesterday's temperature, which makes sense. Oh, we are going to do more. We're not just going to use yesterday's temperature, but maybe we are going to use a window within which we're going to take the mean of, say, average temperature of the previous 3 days. That makes more sense, right? Instead of using only one data point from past, you can use the average of the last 3 days. And then you have a window and you can shift that window. We're going to see that too. All right. And by the way, I'm checking the time. All right. So next, now I'm going to create instead of just 1 day. So let's do this for 3 days. So what I'm going to do is, again, as an exercise. So let's just copy this without making things more complicated. Let's just copy this part. Okay. Let's copy this part here. Okay, as an exercise. Okay, so this is the original data set. There is no lag or whatever. So this is my original data set. Now I'm going to create 3 lags. Okay, lag versions of the original column temp. So TF, I'm going to call it lag 1 to 3. Okay, so again, this time I'm using the whole code here. Okay, this one. So instead of using one shift, I'm going to do this multiple shifts. So let me just copy this, bring it over here. Okay, so instead of making one shift, I'm going to do multiple shifts. So that's why I'm going to put it as a list, right? So let me. Okay, and this is lag 1, and this is lag 2, and this is lag 3. All right. And the next thing is I'm going to put my the data frame, this one. Let me just copy this. And let's put everything together here. And this is the lag 1 and 3. I hope you guys are following. I didn't do really a mysterious thing here. Instead of shifting by 1, I shifted my original column of temperature 3 times. 1 shift, 2 shift, and 3 shift. And then let's see. And it gave me an error. Okay, what is that? PD, next column date. I don't see anything. Okay. Let me silence this for a while, and then I'm going to show you something. Silence this. Okay. So let's see how this one looks like. Okay. Let's see how this one looks like. So you see, you need to check your data all the time as you are dealing with your data set. Oh, by the way, is there any? Okay, so there isn't any. Could you explain how you created temp plus 1? So Sonia, I am now explaining temp plus 1, temp plus 2, temp plus 3. Hopefully this example is going to answer your question. If not, please let me know. So one thing happened here is, as you see, I have temp, and then, yeah, this is 1 shift, 2 shifts, 3 shifts. But I mean, I have 3 rows. Actually, I want to have a format like this, right? So I want to have my the dates as the indices, and 3 temp values, temp plus 1, temp plus 2, temp plus 3. That's what I'm seeing here. So what I'm going to do is, as I did earlier, I'm going to take the transpose of this data set. Transpose, and then I'm going to run this one more time. Hopefully, this time it is fixed, right? So now I have the dates and then temp. So I also need to name these guys properly. So let's do it. So it's going to be better to name them now. So I am going to name the columns as following. It's going to be temp plus 1. Plus 2, and then temp plus 3. Okay, so let's do this one more time. Beautiful. So I have my columns named temp plus 1, temp plus 2, temp plus 3. Now let me merge this, concatenate it actually with my original data set. Okay, and then this time I'm going to see how my original data set looks like. Okay, perfect. So this is my indices, the dates. This is my original temperature. And now temp plus 1 is corresponding to shifting the original column by 1. And by the way, if I ask you, can you please shift this data for each month? Can you please shift this data for each month? Here, I'm shifting the entire data set. So sometimes it might be more meaningful to shift your data within a certain group. So for that, you need to group your data by. Maybe next time I'm going to give you one example like that. So things can get really complicated when you want to make shifts within groups, and you might need to do that. I had a lot of cases where I had to shift my data within the groups. In that case, you're going to first group your data by a certain, let's say, month, and then within the month, you are going to create shifts, okay? But this is a very simple case. We're just learning what it means to shift my data. So 2 and 3. So one thing you noticed, I have not a number, not a number, not a number here. The reason is when I shifted this guy by 1, so I don't have any data earlier than 1981-0101. That's why I have a missing value here, all right? So you need to be aware of this, okay? Later on, maybe you have to deal with these missing values, but you need to be aware of this. All right. Okay, so we are on track now. So we learned how to shift our data by 1, by 2, by 3. Next is I am going to have a window, and within that window, I'm going to do some operations as simple as taking the sum or taking the average. Let me see if I have any. As I see the postings, I'm just checking. Yeah. Yes, Sonia, I hope I answered your question. Okay. One more time, let me just copy this. Okay, this. So I still am dealing with my original data set. Okay, df.head. So this is my original data set. So okay, now I'm going back to my original data set. I'm going to do something more on this data set. Okay. So this time what I'm going to do is, first of all, I'm going to shift my data by 1, and let me call that shifted column as shifted, okay? So I'm going to take the, what is that, df temperature, and then I'm gonna shift this by 1 and turn it into a data frame. And I have it shifted, okay? So it's not a big deal. We already did this before. Let me just show you what this is. Okay, I just shifted my data by 1. Okay, after I shifted my data by 1, the next thing what I'm gonna do is I'm going to define a window. So let's do it first, and then let's talk about it, okay? What I'm gonna do is I'm going to define a window on this shifted data frame. Shifted, okay? The window is going to be a rolling window of 2. And then I'm going to say window equals 2. So let's see what this means. As you see, window is an object now. It is a rolling window of 2. So what we are doing now is we are creating a window of size 2. The 2 means 2 observations. So at each time I am looking at my data set, I am looking at 2 data points, consecutive 2 data points. So shifting the window means the next time I'm going to look at the next 2 consecutive data points, and then the next 2 consecutive data points. So whenever I am focused on a row, I am considering a row before that row. That's what it means, window of 2. Whenever I'm looking at this row, 0, 1, 0, 2, I'm considering this row and also the row before this one, okay? Okay, but when you say, what is window in here, you don't have any value as of now because we haven't done any operation on it, on each window yet. We haven't done an operation. We are going to have a value then once we have an operation. Okay, let's do the operation. Let's take this window, okay, and then take the mean. And then let's see what happens. Okay, so for this, maybe it makes sense to also put the shifted in here. Let's use the head, and let's use that. Okay, so this is my original shifted data, right? And this is the data that I created from shifted using a window, rolling window of size 2. So what happened is I took 2 data points, consecutive data points, and took their mean, and record it. So first, for example, for 1981-01-01, I don't have any data point before this one. So taking the mean of nothing and not a number is nothing, not a number, right? Then I go to the next row. So there is one record here, but I don't have a previous value. So taking the mean of these two, again, is not a number. Next, I went to the next line, 0103. Again, I'm considering a window size of 2. Now I'm going to take this guy, where this is where I am now. I'm going to consider this guy as well as the record from the previous day. That's window size of 2, rolling window. So I'm going to take the mean of these two, and that is the mean of these two. So again, when I am at the next line, I'm going to consider this guy as well as 1 before this guy and take the mean of these two. That is what rolling mean of window size equals to means. All right. It's very useful. It's very useful. You can increase window size, and you can even, we're going to learn shortly, you can even may not consider any window, but as more and more data points accumulate, you can consider all your historic data. So wherever you are, you can consider everything before that day. Okay, you can do that too. We're going to see in a moment. I'm checking the time. I have 10 more minutes, all right? Okay, next. So we now learned about rolling of window size equals 2. So we know what it means. The next thing is I'm going to concatenate my mean. So let me assign this. Let me assign this to a new variable, means. Okay. So I'm going to concatenate, pp concatenate my original data set, which is my which is means. Okay, not original, means, and shifted. So now I have this is my original shifted value, and this is the mean. So let me change the order so it's going to be more meaningful. Let me change the order. Okay, and I'm also going to name these guys. So let's call this df lag mean, okay, lag 1 mean. Okay, and then let me assign the df lag 1 columns. Okay, let me assign the column names. So the first one is t plus 1, right? T plus, sorry, plus 1. The second one, which is this one is t mean of t minus 1 and t. So let's see how it's going to look like. Just 1 second. Let me say df lag 1 in head. Okay, so let's see what is happening here. So this is t plus 1, means I shifted my data by 1. Now I'm taking, using a rolling window size of 2, taking the mean of consecutive 2 data points for each date, okay? And that is the mean of the previous day plus, for example, if I'm here, this is the mean of this day and the previous day, okay? That's what it means. This is the mean of, actually, if you compare this to the original data set, this is actually the mean of, if t is the t of the original data set, this is the mean of t minus 1 and t minus 2, right? If you think about it. Okay, let me check if I have any questions. No questions. Okay, so the next, what I want to do is, again, let's do a little bit more exercise on this rolling windows. Again, let's go back to our original data set. Let me just copy this. Okay, let me just copy this. It's easier to copy and then go back to the, instead of assigning new data variables, I'm just using the same data over and over again. Okay, so this time, what I want to do is, I'm going to create a rolling window of size 3. So each time I'm going to take 3 data points, consecutive data points. Out of these 3, I want to find the mean, the minimum, the maximum, and the average. Okay, so you can expand this time window size from 3 to 5 to 6. What happens is, I'm considering, say, 3 consecutive days. I just want to pick the minimum value of these 3, the maximum value of these 3, and then take the average of that. And then I want to record these as separate columns into a new data frame. Okay, that's what I want to do. So let me just run this first, and this is my data frame. The next thing is, again, I'm going to, this time, have a width of 3. So the window size is 3. And first of all, let me shift my data by 2, and then you will see why I'm doing this. After this one, I'm going to stop, all right? This is the last thing I'm talking about. I'm going to stop. So width is 3. What I'm going to do is, similar to what I did earlier, I'm going to create a new data frame, a shifted version of my original temp column, but this time I'm going to shift it by 2. Okay, so df temp. Right? I'm going to shift this by, you can shift this by 1, by 2, by 3, depending on what you want to do actually. But what I want to do is, I'm going to make this shift as a function of width. Okay, so width is 3. What I want to do is, I want to shift my data by 1 less than the window size. That's what I want to do. And again, there is a reason for that. We are going to see shortly. I want to shift my data by 1 less the window size. So width minus 1, right? At this, what is this? Width minus 1. Okay. All right. Okay, this is shifted. Next. Now from shifted, I'm going to create my rolling windows object. But before doing that, let me turn this into a data frame. And then here is my rolling window object. So let's call this window shifted. I take the shifted version. I'm going to define a rolling window size width. In this case, it is 3. Okay, let me run this. Okay, we know that window as of now is just an object. So I need to use the methods of this object, which can be min or max or mean, right? So we already used mean. This time I'm going to use mean max in addition to mean. Okay, so what I'm going to do is, I am going to create a new data frame. Let's call this a new data frame. So new data frame. This data frame is a concatenation of, okay, of my original data set. Okay, my original data set. And I'm going to take my window and then take the minimum of that. We'll see. So what happens is, now I'm taking 3 consecutive days and finding the minimum of that. Again, I'm going to take my window and find the maximum of that. Again, I'm going to take my window and find the means of that. Okay. All right. Maybe I can also add shifted too. Okay, so I have the original data set, the shifted version, a minimum, maximum, and mean of each window size. Wow. Okay, this is really, it's going to be a long thing. Let's see what we're going to have. And then this concatenation is happening based on x is equals 1. Okay, I'm just putting together horizontally data frames. All right, and then let's define the, first of all, let's run this and then see how it looks like. They are all temp, but this is my original data set. This is the shifted version of that. Remember, I shifted it by 2. And then strangely, I have 5 missing values here, and then we'll explain what is happening here, okay, in a minute. But before doing that, let us also define the data frame columns, okay? It's going to be, this is the temperature. This is temperature. This is temperature +2, right? And then this is min. And then this is max. And this is mean. Okay, perfect. Now let's think about what is happening here. So this is my original temperature. This is the same thing shifted by 2. Remember, my window size was 3. So for any date, I am considering the data point on that day, and also as well as 2 days prior to that. But I did this window rolling on temperature +2. In other words, I am considering this column when I am creating a rolling windows. Okay, so don't be confused. I didn't consider my original data set. I considered the 2 lagged version of my original data set when I created rolling windows. So remember, window size is 3. Okay, so in that case, I'm going to talk about 10 + 2, right? I'm going to take this as the base for now. So the first the first value is actually not a number, right? So in that case, there is nothing before this coming. So the minimum, the maximum, or mean is all going to be not a number. Next, again, the previous number is not a number. Before then, there is nothing. Again, there is no minimum, maximum, or mean. Next, this is 20.7, but 2 values before 20.7 are not a number. That's why the mean, the max, and mean are all not a number. Next, 17.9, the 2 values before 17.9, one of them is a value, has a value, but the other one does not have a value. Again, you can try. You can create a NumPy array of 3 numbers. One of them is, let's do it very quickly. Let's do it very quickly. NumPy array of, let's say 2, 5, and then you see it's none. So let's check the maximum of this. It's again not a number. Let's check the mean of this. It's again not a number. So when one of your values in an array is not a number, mean, max, or mean are all going to be not a number. It's not going to, so when NumPy mean, max, or mean is working, it is going to consider not a number as one of the array members. Okay, finally, on 5th, when I consider 18.8, this, the window size is 3. This is a number. The one before this one is a number. The 2 before 18.8 is also a number. Now I'm considering these 3 numbers. Minimum is 17.9 out of these 3. Maximum is 20.7. And the average of these 3 is this. So you can be very creative and generate new features from your time series dataset by using, in this case, rolling windows and methods implemented on rolling window object. Okay. So in our next meeting, I'm going to continue with how we can actually use, in addition to rolling windows, can we also use a expand method of pandas? And on top of that, now can we use these new features to make predictions for the next time period, okay? And then we are going to consider how well our prediction is working. And this is very primitive, very primitive. We are not even using any time series model yet, okay? But I think we are getting a good understanding of how we can manipulate time series data sets, how we can generate new features from time series data sets, and then how we can read data, turn or parse data type into datetime type. So that was the plan for today, but I couldn't finish today's lecture. I'm going to today's session, not a lecture. I'm going to continue from where we left, and then hopefully I will also have some exercises for our next meeting. All right. I'm going to put this file into the folder that I shared with you so that you also have what I typed in here, right? So, but until next time, please take care. And sorry about the interruption when the internet was gone. I'm going to stop here for today, and I'm going to meet with you guys next time. Hopefully next week, you're going to receive an email on that. Okay, thank you for listening, and I'll be here for 1 more minute if you have any questions. Okay, you're asking about books. Let me, there are very simple, there are books which are talking about time series in a very simple language. Let me put 2-3 book names together next time. So I will share it with you. I don't remember the, we are going to get into ARIMA, all these more advanced time series models. Of course, hopefully in our 4th session, if I can finish what I planned, that is my goal, getting into the time series forecasting models and then compare evaluate their performances. So that is what I'm aiming at. But before that, I think we should be comfortable with the data set. Okay, thank you very much. I'm going to see you guys or talk to you guys next time. Take care.